Welcome to Unit 4, Lesson 4, Positive Rational Exponents. Let's use roots to write exponents that are fractions. Okay, again, take a note of our exponent laws. We're going to use these constantly throughout this unit. When it comes to, let's look at 4-1. When it comes to multiplying, it doesn't matter the order in which you multiply. So we're going to do 1/2 times 5 times 4, which is 20. Now, any rational number can be put over 1 to make it a fraction. When we multiply fractions, tops multiply tops and bottoms multiply bottoms. So 20 over 2 is 10. So if you remember your cross multiplication, 2 goes into 2 4 times. The common denominator is 2, the common factor. 2 divided by 2 is 1. 4 divided by 2 is 2. So this becomes 10. The 2's cancel out. The 3's cancel out. And you're left with 7. So let's do this. 2 times 7 times 3. Now I'm going to move the numbers around in the bottom. It's 2 times 1 times 3. The 2's cancel out. The 3's cancel out. So let's do this a little neater with the last one. 7 times 5 times 3 over 3 times 7. I'm going to move this around to 3 times 5 times 7 to be 3 times 1 times 7. We can see the 7's and the 3's cancel out, leaving us with 5. Okay, we're going to, 4-2, we're going to use exponent rules to explain why these expressions are equal to one another. So 5 to the 2/3. We can break a fraction up into 2 over 1 times 1/3. And when it comes to multiplying, not 5 equals, I'm sorry, it's not equals. It's 5 to the 2 over 1 times 1/3. So we can do 5 squared to the 1/3. We can do 5 to the 1/3 squared. So because we can add and multiply in any order, it doesn't make a difference. 2 times 3 is the same as 3 times 2. So if I move if I separate the first one around and I move them around, it doesn't matter which order we go in. And that's going to be helpful when we have to simplify an expression later. Okay, write 5 to the 2/3 using radicals. When we use radicals, we need the root. Now we had to figure out what is what. The 2 becomes an exponent, and the 3 becomes the index, or the root, or root. Okay, so the 3 goes here, the 5, the base stays the base, and the 2 is the exponent. So when we look at square roots, index or root gets written right there on top of this. This is called the radicand, and the blue part is called the radical. The radical is a funny looking division symbol. It's a special type of division where you get the same number multiplied to itself. And these are parts of a root or radical. Okay, so looking at number 3, write 5 to the 4/3 using radicals. If 4 is my exponent and I take it to the 3rd power, I can also write the cube root of 5 to the 4th power. I can write 5 to the 4th power, the cube root, which is just like what I wrote the first time. So when it comes to exponents, you can separate them and switch them around, switch the order, and you get the same thing. When adding and multiplying, you can switch the order of what you're adding and multiplying. Okay, you can calculate these numbers on a calculator, but 2 to the 0 is 1, 2 to the 1 is 2, and 2 squared is 4. And these decimal approximations are going to be in between. All right, so 2 to the 1/3 is going to be closer to 1, 2 to the 2/3 is going to be closer to 2. Okay, what this is supposed to look like is supposed to curve up. It looks like a straight line. That's because everything is spread out so far. The square root of a function is supposed to look like this. But it's a little off because of what we're graphing. Or a root function is supposed to look like the little graph I drew. All right, select one of the columns. Write the power from the second row of the column that you chose using radical notation. What is the exact value of the number that is cubed? So if I take one like 2 to the 1/3, I know this is my exponent. The top, the denominator is my root. So this is a cube root of 2 to the first power. The exact number is cube root of 2 to the first power. Because 2 is not a perfect number, anytime you take any root of it, cube root, square root, it is not a rational number, which means its decimal does not repeat, it does not end. So when we want an exact number, leave the radical because this is exact. If you take a decimal, you're going to round it off. So if you round off a decimal, it will get you close to 2, but it won't exactly be 2. So C is a little inaccurate of a question, and we're not going to worry about that.